Again, one more time, good afternoon to all. Myself, Santosh, working as product specialist. I had an experience of 5 years, which is of 2 years in the design industry and 3 years in the CAD center. So 2 years I worked as a product engineer. Then I moved to the CAD center, which is a product specialist. Usually, I'll be handling CA products, which includes like Ansys Workbench, Ansys Fluent, Hypermesh, LS Dyna, SolidWorks simulation, and NXCAD, and a bit of modeling software like NXCAD, Autodesk Inventor, and SolidWorks Motion, and a bit of AutoCAD. I'll be handling all this, almost 9 to 10 products I'll be handling. Yeah. So this training will be continued from today to up to 5th March. Saturday and Sunday we don't have trainings, as you know. In the mail itself, there it is mentioned. And every day I'll be giving you the assignments. For every day I'll be giving. Please mute your voices. If you have any sort of doubts, you can just text in the chat box, or you can unmute and you can talk to me, because sometimes you'll be getting disturbance from other end also. You should not be get disturbance to the other people. So that is the intention, I to make your voices to mute. So next, as I was talking, like every day I'll be giving the assignments. Even I'll be sharing the task, I mean the task what to do, and I will be sharing the hands-on files. So before we start of the session, you have to complete the previous day assignments. That is mandatory. You have to complete that assignments. I'll be looking that, and I'll be generating the report, and be that report is sending to the corporate office as well as to the centers. Have you done the assignment or not? Based upon that, we'll be finalizing, or we'll be seeing that how long you've been practice and what you did in that. Okay. Yes. So I'll be starting the application. I hope you can see the screen. So what I do is, I'll give it today, I'll be talking about the introduction part. Yes, four of you, what do you know about CFD? What you know about CFD? What do you do in the CFD, or the Fluent?
Computational fluid dynamics.
Okay.
And
Yes,
fluid.
computational fluid dynamics. What you're going to analyze, or what you're going to study in this software?
So fluid flow related analysis we can do, pressure drop, velocity, flow
Mm-hmm.
rate, these kind of things we do. And
Okay.
in gases we can check radiation things, radiation those things also we can.
Mm-hmm.
And,
Okay, that is also
yeah,
one valid.
yeah.
Okay. What
Air,
about
aerofoil profiles also we can check their
what
lift
aerofoil
drag,
profile? What you will check it in that?
lift drag, these kind of things we can, lift forces, drag forces, and airflow flow
Mm-hmm.
stream types we can check.
Okay, good, nice. And what about the other people? Gokul.
Yeah, yes, sir. I am Sean was.
Yes. What you going to learn in this?
Yeah, it's mainly for simulation to the maintaining for products.
Mm-hmm.
We have to analyze we have to growth for how kinds of we have to implement it for aerodynamical the structure of its flow for proving the components. It's analyzing preventive actions for proving the components.
Okay.
Yeah, like
Yes.
how to CFD is mainly main theme for like it's now currently for current companies we have to most of like we have to using that. So like
Yes. Ranjit. Good afternoon.
Yes, sir.
Yes, you're from which center?
Sir. From Anamega, sir.
Okay, please come near to your mic so that it will be audible for me.
Okay. Is it audible now?
Yes, it's fine now.
Yep.
Yes. Uh, can you
Sir,
introduce
I just
yourself?
I know. Yes,
Introduce yourself.
I'm Mr. Ranjit, and yep. So I've been a part of CAD Center for 1.5 years.
Mm-hmm.
So handling more than 7 softwares like SolidWorks Motion, and Ansys Workbench, and Hypermesh also. So
Okay.
now,
Okay. So
so now we
present you are
took
taking.
Ansys Fluent.
Okay.
Yes,
Okay, fine.
it's all about.
Yes. What do you know about CFD? What you know
Yes, sir.
about CFD? What you know about the CFD or
About
the
the
fluid?
Ansys.
No, no. I'm talking
Uh,
about what the
it's,
idea you have about CFD.
hmm. Uh, we can do okay. I know the only difference between the workbench and CFD is, so in workbench itself, we only working on a single phases. Like if it is a solid, we only stand alone working with solids, the interaction between the solids. But when we came to CFD, the multiple phases, like the interaction between the two solids, I mean not solids and liquids, not only gases and then liquids, like aerodynamic analysis and then flow of the fluids, we can accurately capture the volume based analysis.
Okay, good.
Yeah.
So first, I'll talk about the introduction part. So CFD is a compilation of fluid dynamics application. The application what we are using is Ansys Fluent. In every software they have CFD. Even in SolidWorks also we have CFD. In Creo also we have CFD. Any application. But why this Ansys Fluent became very popular? Because we do n number of n type of application we have in Ansys Fluent compare with the other softwares. So that's why this Ansys Fluent has become very popular in the market. So what this CFD? CFD is a science of predicting or finding or deriving fluid flow, heat and mass transfer. What is CFD defines? It is science of predicting fluid flow, heat and mass transfer, chemical reactions and related phenomena by solving numerical set of equations. By solving set of numerical equations. So one is conservation of mass, conservation of momentum, conservation of energy, conservation of species. So these four types, the four types or the basic four types which is interlinked or the background theories of your Ansys Fluent, and as well as computational fluid dynamics, the course we have in our engineering. Might be we have a core subject for mechanical people, we have a core subject computational fluid dynamics we have, so which is having fluid dynamics, or we have fluid dynamics. Okay, so that we core subject we have in terms of 3 2 or 3 1 semester we used to have that. So their total will study about the properties of a fluid, how the fluid is to be reacted, how the fluids having velocity, what properties and what types it is depends upon. So that all we studied in the theoretical. So that theoretical knowledge we are going to put it in the application to see the practically how it is going to be happen. Okay. So then before in 1970s the complex mathematical required equations generalized algorithm began to be understood, like theoretical calculation they used to do, but CFD solvers began to appear in early 90s and required very powerful computers as well as in-depth knowledge of fluid dynamics, a large amount of time to set up the simulations. But recent advances in the computer power, together with powerful graphic results, much less required, less labor cost, reducing the time, and hence the cost efficiency also can be increased. I mean, cost efficiency also can be also reduced. So now CFD is an industrial design tool helping to reduce the design time, scale and improve the process throughout the engineering world. CFD provide cost-effective and accurate alternate to the scale model testing with variations in the simulation performed quickly. We can solve one model with different properties. Okay, so on what basis this CFD depends? They should be have some certain parameters to before we start off learning something. We should be knowing some basic things. Okay, you take any sort of suppose you want to study about any kind of design thing, you should know some basic ideas like isometric drawings we have to understand, then we have to able to draw it. But same similarly, if you are learning about the fluids, definitely you have to know the properties of that fluids. Okay, that is very important. Suppose I want to learn some design skill, definitely you should be knowing the engineering drawing to know how to draw like isometric views, first angle projections, so section views. You should be aware of that, then only it will be easy to understand the drawing. Then the same similar, if you want to learn about these fluid properties or the fluid you want to analyze that, definitely you have to know the properties of the fluid, how it is going to be reacted, what changes going to be happen when it's heated, or how the pressure drop is going to be happen. So that all parameters you should be known, then only it is easy to understand. Okay, so the properties of fluids. So when I talk about fluids, think that fluids are fluids. When I talk about fluids, every time fluids, it consists of liquid and gaseous. You know fluids is nothing but liquid and gaseous. Liquid which comes under mercury, water, all this some kind of gaseous, air, carbon monoxide, high nitrogen, oxygen, this all. So when I talk about fluids, no, you think that both the cases, gaseous as well as liquids. So on what basis this fluid depends? So fluid depends upon density, viscosity, temperature, pressure, specific volume, specific weight and specific gravity. So the important things are this four important: density, viscosity, temperature and pressure are the four important parameters. And this usually they have specific volume, specific weight and specific gravity. So what is meaning of density? What you mean of density? Density is a mass per unit volume of a liquid. In other words, it is a ratio between mass to the volume. Okay, how you define mass to the volume? That is units for kg per meter cube. Now, in the general, density of fluid decrease with increase in temperature. It increase with increase in pressure, but it decrease with increase in temperature. Okay. So now based upon the ideal gas equations, that is of PV equal to MRT. So when you know pressure mass by volume, that is RT, where R is a universal gas constant. So P is equal to pressure, which is indicates rho RT. This since pressure is mass to the volume. Now the next case is the above equation is to define the of a fluid where pressure and temperatures are known parameters. Usually for basically the standard density of a liquid is 1000 kg per meter cube. Okay, so this the general notation we have, 1000 kg per meter cube. And next coming to the viscosity. What is you meaning of this viscosity? Viscosity is a fluid property that determines the amount of resistance or opposing forces of a fluid to shear stress. It is the property of fluid due to which fluid offers resistance to flow of one layer of a fluid over with the adjacent layer. The opposing forces, we can call this as a viscosity. In liquid, viscosity decrease with increase in temperature. In gaseous, viscosity increase with increase in temperature. This is the basic logic we have to understand. And comes to here temperature. What do you mean of this temperature? It is the property that determines the degree of hotness or the coldness or the level of heat intensity of a fluid. Temperature is measured by using three scales, mostly like Celsius, Fahrenheit and Kelvin scale. Right? You can change the units also, depends upon the model requirement or the problem description will be changing the units. That is not going to be a problem. So next is pressure. This is one important parameter. Pressure of a fluid is a force per unit area of a fluid. In other words, it is a ratio of a force on a fluid to the area of a fluid held perpendicular direction to the force. So pressure is denoted by letter P. The units for is Newton per meter square. Newton is a force per meter square. So units we can remember in that way. Okay. So in other words, is a ratio of force on a fluid to the area of a fluid that holds perpendicular to the direction of force. Okay. And the other parameter we have is specific weight. So how you define this specific weight? Guys, if you have any sort of doubts, please unmute and you can talk to me, or you can just text in the chat box, sir, I'm not able to understand in the particular area, can you repeat that step? Sure, 100% I'm going to repeat you that. Okay, so please understand that this is my sincere request. Any doubt, please raise the question. And comes to here specific weight. Specific weight is a weight possessed by unit volume of a fluid. It is denoted by symbol W. The units are Newton per meter cube. Okay, specific weight so varies from place to place due to changing in the acceleration. What is the meaning of accelerations? The changing in the velocity due to gravity. Okay, so specific weight is a weight to the volume, that units are Newton per meter cube. And comes to the specific volume, the amount of volume of a fluid occupied per unit mass. So it is reciprocal of density, that is of meter volume to the mass. Okay, and we have specific gravity. So how you define this specific gravity? Is a ratio of specific weight of a given fluid to the specific weight of the standard fluids. So it is denoted by letter S, and it doesn't have any units. So gravity, weight of a given fluid by specific weight of a standard fluid. So standard fluid weight is how much? Okay, so that we have to know, as the density is 1000 per kg per meter cube, right? So that we can have. So on what basis this fluent will be having more prominent role? So here we have the applications. One is automobile. What you can find in automobile? There are a lot of applications, as we can find drag forces, lift forces we can find in automobile, as well as in the same as in aerospace, like airfoil, we have jet engines, you can find it in that. So in terms of marine, you can find the aerospace, in terms of marine you can find the fluid properties when ship buildings are moving. And comes to the biomedical, what we have in the biomedical in terms of chemical reactions, when when two fluids are interacting, or when two gases are reacting, that you can find in biomedical. And military, so like hot gases or hot fluids, that which is moving in the military, how the bomb explosions, that you can study in the military type. So comes to the civil, like we have two different parts in terms of civil, when two compositions of concrete or composition of sand, how it is going to be reacted, so that you can study in this civil applications. Come to the chemical, so how you have composition reactions of nitrogen, oxygen, or methane or oxygen, how it is going to react, that you can study in the chemical in terms of application. So every domain we have this fluent which will play a key role, right? So apart from this basic parameters, apart from this basic properties, you also have different properties which we comes into the exist. So that also we are going to apply in the software. So but these are the main standard properties. These four are the standard properties, but this might be changes: specific volume, specific gravity. Sometimes we'll apply and sometimes we are not going to apply, but these four important parameters are usually we'll apply: density, viscosity, temperature, and pressure. Most of the times we used to apply. Okay, apart from this we also apply some other inputs that I'll be telling you when it comes to exist. Okay, so what is meaning of this Ansys Fluent? Why it has become popular? As I mentioned in my first word, so Fluent is a state of art computer program for modeling fluid flows and heat and chemical reaction in the complex geometries. Ansys Fluent provide complete mesh flexibility, because What is the meaning of mesh flexibility? Because hypermesh is one flexible software, or no, one good meshing software. Mesh flexibility, including the ability of solve your flow problems using unstructured mesh and structured mesh. So what are you meaning of this unstructured mesh, which doesn't have any no, the irregular mesh pattern? Okay, that can be generated about complex geometries with related to case. And supported mesh types are including 2D triangular elements, quadrilateral 2D triangular or quad elements, or hexahedral or tetrahedral, no, triangular elements or quadrilateral elements. And in terms of 3D elements, we have tetrahedral or hexahedral, pyramid, verge or polyhedral elements. And also we have mixed hybrid meshes also, which can be supported in Ansys Fluent, because mesh will play a key role in your simulation, right? So that's when you have a good mesh, definitely your results will be accurate, depends upon the complexity of your problem. So how this CFD methodology will work? Okay, the first thing is you have an example. I'm going to show you how you have to define. Suppose you have a geometry. I have this pipe section. Okay, assume this is a section view of your pipe section. Now what we are going to do is, now I have the portion, so which is fluid is passing from this region. Okay, from this region the fluid is passing, and this is your outlet region. This is your inlet. Now what you can do is, I'm going to mention this is your inlet portion. Okay, so this is your inlet. This is inlet, we can mention, because the system cannot understand which is inlet and which is outlet. Okay, so I have to define each and every parameters. This I'll go for outlet. Okay, so this is outlet. Now these two things are, now this portion, this and this are my walls of your pipe. You can go with here pipe walls, you can mention this. Okay, so this and this other pipe walls. Now when the fluid is passing, any one of you have four, I think today we have 5 participants, right? So you tell me guys, where will be the maximum flow will be there in this pipe section? Where will be the maximum flow will be there?
Center.
Why exactly in the center?
In the wall section, it will resist.
Good, nice. See, now as your Gokul said, that is a true. So now from here to here, exactly in the center, flow will be constant. Okay, we know that basic. So as per our knowledge, as per we done the experiments in our engineering labs or fluid dynamics labs, so the constant flow will be there exactly in the middle of your pipe section, and rest of the things will be irregular. Now here we have this area, due to viscosity in nature, the walls will have less flow, constant flow will be we have, right? Now if I go with the general mesh of this, if I go with the general mesh, I'll get the results. To be frank, you will be getting the results, but thing is that you want to have fine results, then how you have to generate the mesh? Now you have to generate fine mesh. The first foremost thing is, we have to give the named selections or create a named selections, which is inlet and which is outlet, which are the other parameters we have to define. Okay, so from inlet, then we will mention here, so this we'll select this edge and we'll mention this is inlet, and we'll select this as outlet, we'll mention that, and these are the wall sections. Now as per my requirement, what you want to find from this pipe section, I want to calculate the outlet velocity, I want to predict. What you want to calculate? I want to calculate what is the outlet velocity. This is one important parameter I want to find. Again, I want to calculate the friction or skin friction I want to calculate. So this important I want to calculate. All right. So anyhow, you will get what outlet velocity you can calculate from here. You were giving some initial velocity, then outlet what is the velocity it has been having, then skin friction coefficient. So I want to calculate exactly on the pipe walls. I want to calculate the skin friction coefficient. How you find it that? So if you go with the general mesh, it is very hard. No, the results will not that accurate. Definitely there will be changing of 10 to 20% change in the results if you go with a general mesh type. If generally you do auto generated mesh, if you do that, you will get 70% results you will be getting, but not that much 90% or 99% you will not get. So what I have to do for these cases? Definitely I have to go with fine mesh. Okay, sir, how you do that, sir? So I know that the basic logic is the constant flow will be there exactly over here. The constant flow will be exactly over here. Okay, the constant flow will be exactly over here. Now what I do is I'll be generating fine mesh over this region. The top region I'll be generating fine mesh. Okay, so this top region I'll be generating fine mesh. Top region over here also I'll be generating fine mesh here. And here in the bottom also I'm generating fine mesh. And rest of the things in the middle portion I'll go with the default mesh. Okay, so very fine I'm going to generate in this area. So splitting will be very fine. This area very much fine I'll be generating this. And also should be connected with each and every element. I'll be generating that. So that is the basic logic before we start off the problem. Okay, so first what I'm saying is creating the geometry or mesh. Okay, define the physics or physics of your model, what you want to predict, what you want to calculate from the software, that you have to define, and solving the CFD problem based upon what model you want to solve. Either you want to solve by green ghost method or cell based method, and you want to solve by using turbulent flow, kinetic flow, what type of flow you want, laminar flow type, on what basis you want to solve the problem. Okay, so we have to know based on how you calculate this turbulent flow and laminar flow based upon the Reynolds number. What is the Reynolds number that fluid is having? So based upon that we'll decide and we'll put in the inputs. Okay, so then the other case is visualizing the results. Okay, we are okay with the results or the fine result you got it there or not, we'll be checking that. Okay, so that is one CFD methodology. So creating the geometry meshes depends upon my application, depends upon my results, how I have to get it, then I'll decide it, I'll be generating the mesh. And define the physics of your model. What do you meaning of this physics of the model? I'll be creating the name selections, then only I can easy to give the boundary conditions. So how much velocity it has been traveling from here, how much velocity, the inlet velocity, what is inlet velocity, v1, what is the velocity, what is the temperature over there, t1, v1, and what is the velocity v2, and also we doesn't require this outlet because we want to find this outlet velocity. So what is having velocity, how much velocity it has been traveling, what is the density of that fluid, what either it is passing, fluid is passing or air is passing. So I'll be taking the metal from my fluid library. So suppose you want to pass air, what is the velocity of that air, what is the temperature of that air. So that all inputs I'm going to assign to my my model, that we call as physics of your model. Okay, so that we are going to define. So next the other cases is we have planning CFD analysis with Fluent. Define the modeling goals, what goals we require, what you want to predict, create a model geometry and mesh, set up the solver of physical models, compute the monitors and the solutions, examine and save the results, and revise the model. So these are the three important cases. So first I'll begin with one application, how we have to begin. Okay, so first the foremost thing is the version what I'm using is 16th version. You have in the market you can get the newer version also. So how we have to begin this application? Start, Okay, you can just go with the start the application. So 16th, directly you can have directly if you have a mesh file, directly you can go with the Fluent. If you have a mesh file, no sir, I don't have a a mesh file or CAD file, then directly you can go with the workbench. Directly you can go to the workbench. If you have a mesh file, directly you can go with the Fluent. There you can import the mesh file. Right, I'll be using workbench. Yes, so now once we done with the application, so go for here. I think you all knows Ansys workbench, I hope. So what I do is directly I'll go with here fluid flow Fluent. From here you can browse it, or you can just drag and place or double click on that, or any way you can just do that. So what I do is I'll just drag and place it here. Okay, so just you can go with, if you have a mesh file also, you can directly import here mesh file. If you have mesh file, you can directly import the mesh file. No sir, I want to draw the geometry. So what you can do is just click on here. Today I'll be showing some introduction how to start the application. Then from tomorrow we'll start with one problem of how the real-time application is going to work. We'll start with that and we'll solve the problems. So go with XY plane. So you can just draw this. Okay, I'll just taking one component. So what you do is I'm creating 2D. And that geometry, so I'll, here you can, so change type to, here I'll be changing this to fluid. Okay, just try to close this. So first thing is, you all knows like how to generate the default mesh. Right click and generate the mesh. Right click, you can generate the mesh. So if you go with this default mesh, definitely you won't get the better values. So I know that exactly center we want to have, right? So what you do is you can go with the settings. I hope you all are clear with this all these mesh types. Okay, so what I do is I'll go with here sizing. Okay, so in this you can select this edge portion. Then you can go with your no, bias type. I'll go with. So exactly we can go with the middle bias factor of 10. I'm going to use it. Number of divisions, some 50. I'm going to use it here. You can observe it. So fine mesh will be there in the bottoms. Okay. So you can go with here. Again, you can just go with here. You can, yes. So again, no, just fit to the screen of this area also. Okay. So you can just try to generate the mesh. What you do is right click this, you can just go with face meshing, just generate the mesh. Now what you observe, so fine mesh will be there at the walls. So why, sir, why you gave fine mesh at the walls? Because viscosity will be more at this wall region, so viscosity will oppose the force. So that's the reason I've given fine mesh over there. So rest of the things are middle have general type I have. So this way you have to decide your model. Okay. Now the other important cases is then I have to give the name or selections. So go with here, because my system doesn't know which is inlet and which is outlet. So I'll be giving create a name or selections. I'll go for this is inlet. Okay. And this and these are walls. Create a name or selections. I'll go with walls. I'll go with walls. And this region, create a name or selection. This is outlet. I'm going to mention this. Right. So you can have inlet, walls, and outlet. I'm going to mention. Right. So for a future, like if you want to open the mesh file again, because sometimes your file will be get corrupted. For a safer side, I'll be saving this mesh file. Export, so it is saving that mesh file, right, .ms file. So in the desktop I'm saving this file. So what you do is in the Fluent I'm saving this. Okay, pipe mesh. So you want to replace that, I'll be replacing that. Okay, you can save it that, because we require that. Sometimes your file will get crashes, so I'll be closing this. Okay, so it is asking for update, you can try to update it. Okay, you see sometimes it will happen, so it is get corrupted. What you do is again you can go with the fluid flow Fluent, not all the time, sometimes it is going to happen. So right click here, import the mesh file again. So where you've been saved, that file you can save it there. It was saved today only, no, 247. So I'm opening that. Right, so directly you can click on this, the Fluent application will be opened. The starting of the Fluent, this is our Fluent application. So double pressure, I'm going to tell you detail, but you try to observe it. Yes, so this is our file, right? So here based upon this, if you're taking from other software, you can scale it. So check and report the quality. Is there any mesh errors? So display, you have all. So pressure based, steady state, planar. So model, I'm going to use it. So here what type of no, you can take it here. So k epsilon second equations, I'm going to take it. So enhanced wall treatment, I'm going to use it this. So what type of fluid is which is passing? Material. So air was there. No sir, I want to pass it water. Create or edit. In the Fluent database, you can take the water liquid. Okay, I'm going to take this water liquid. You can try to copy that. So density we have water vapor, sorry, I'll go for water liquid. Okay, try to copy that. Okay, so water liquid. So we are making water to flow inside, right? Go for cell zone conditions, surface body, edit it, change type to water liquid. That means the water is going to pass inside. So boundary conditions with how much velocity, the condition we have to give. So inlet, edit it. So how much velocity it has been traveling. Okay, so I'll go with the velocity of some 2 meter per second it is going to travel. So try to give. And the specification intensity and hydraulic dia of this pipe section, intensity 5% I'm going to use. Diameter of this I go with that 2.5 we gave it, right? I'll go with the 2.5. Might be, so you can, what I hope, what how much length we gave, this is of 35 and this is 2.5, right? That's I've given this. Yes, so go with dynamic mesh because mesh is already done. Fine mesh reference values I'm not going to use it. Solutions, simple method I'm going to use it. At which region you want to check the results, create. So what you want to check it, so I want to plot at the walls. So you can develop a graph over there. So what sort of results I want to see that. I'll go with flow rate. Which region you want to see the flow rate? So I want to see in terms of pressure, which region. So pressure coefficient I want to see, at region of outlet I want to see. You can just, so that you can generally solution initialized. I'm going to initialize this inputs. So run the calculations. I'll go with of 300 iterations. I'll tell you what is meaning of the iterations. So once you have done, try to calculate the inputs. So this is the flow rate how you have. This is the flow rate. This is the general cases how you have. So the iteration has been completed, but we gave for 300 iterations, but it has been completed at 54 converts. You can see the results. Go for graphics, counters, setup. We have general pressure. I want to see the pressure. Try to display that. Just change it to counters of pressure. How we have. So pressure more at this region, the inlet region. Okay. So I want to see at the velocity how the velocity is changing. You can go with the velocity, which is maximum velocity, max you have very much. The red color indicates the maximum because we gave 2 meter per second and the total length is 30. We have, and what the turbulency, how you have the turbulency. You can see the turbulency and turbulent intensity also you can check it this way. Okay, so mostly I'll go with the pressure, how much pressure which is having. Okay, we can just go with that. So maximum is 1.4 you have. Okay, so can you have this any sort of animation? So what you do is just close this, then you can go to the post process, CFD post process. Just go with here. Okay, so we can display the symmetry 1. So go with the counters and go with it. So I want to see the pressure. You can go with the pressure. We have for symmetry 1 region. You can rotate and you can see it. So I want to see that which is having 1.4 you can live, or you can go with here symmetry 1 region, try to apply it. So how we have the pressure. Okay, you can just put it here. Pressure I want to see including the velocity also. You can see the velocity. Okay, so gradually if you observe clearly, now you can see gradually it is decreasing here in the walls regions. It is keep on decreasing. If you zoom this area, it keep on decreasing, but here it is having the maximum, right? The maximum velocity is at this region. Just put it here. You can observe it. You can keep on changing the velocity and you can cross check it that. Okay, now sir, can I have any sort of animation how the fluid is moving? Yes, we have that. Go for here, you can go with the streamlines. I'll undo this, the previous cases, counters, I'll undo this. So go with streamlines. Okay, so you can go with here all domains starting from the inlet region. Okay, so just what velocity you want to see, that you can see how the velocity which is showing red indication, that is maximum you have there. So you can increase this number of points. Okay, so then what I do is I'll go with the animations. So you can play this, decrease this frame rates, okay, which will have very much speed, and this also. Once we're done, try to play this. You can see how the fluid is moving there. Okay, you can just stop it, that just increase a little bit frame rate. Because I reduce the speed, but our ultimate thing is this is our value. 2.5 is the maximum velocity you have it there. Okay, so you can put it here. Try to play it. I'll be changing this type. It required more graphics. Whenever you do heavy complex problems, we required more graphics. You can go with again animations, go with options. How this fluid is moving, you can cross check that. Right, so this way like we'll have different sort of examples you can work out. I just show you a small workout how we do that. Okay, just you can stop it. So what you learned today, any one of you? Yes, other persons also joined today. Okay, so what you learned, Gokul, Ranjit?
Yeah, sir.
Yes, Shanvas, what you learned, what you understood till now, since for 1 hour, what you learned?
Yeah, sir. Basically for the
Fluid.
Anyone?
yeah, sir.
Yes.
Yeah, sir. Basically for it's a how to so decide that for structure the component to deciding that to analyzing the to our basic, we have to some velocity is main thing for our main. So we have to how to conduct the flow of its compress the velocity. So like that. So like that based on tooling, little bit tooling based. So
Okay. Then what about Gokul? What you understood?
From this, how fluid is behaving from one point to another, the pressure drop like
Okay.
that.
That's all.
Its flow rate and how it is behaving from one end to another end. We can visualize in graphics also, and we can see the flow, how it is moving.
Okay, good. And what about Kishore? Kishore, you are there? Okay. Ranjit?
Yes, sir. Is it audible?
Yes, I can hear you. What you learned? What you understood?
Yes, sir. Uh, so it's a simple problem throughout a pipe station. So for everything, like in workbench, we have a set of steps, right? So first
Yes.
we need to define the engineering data and then geometry and try to mesh it, and then given the boundary condition and looking for the results. So likewise in the CFD also, the first thing we need to do is a creation of geometry, and then defining the wall creation, and then try to create a better mesh comparing to that workbench also. And once we created that, and we'll move on to the Fluent environment, and we have so many things to define the general conservation of equation like masses and then diffusion factors, and accordingly we have to first define that. Once we define that, we need to assign the boundary conditions like inlet condition and outlet condition. Once we given that, we will move on to the solutions and looking for the convergence, whether the problem is convergence or not, and we'll move on to the CFD, the CFD post, and view the results. So the overall basics, but we don't yet get into the core of the site. So why we are choosing laminar flow other than that?
Yes.
So that is what basically.
Yes, Sahil has raised the question, how to add properties, basics of the fluid, how to put the values and how the fluid flows. See, we have every property that we have to define. What is like density, all. When you add the material, no, in that material step itself, we have the inputs. Okay, so we have the inputs. If you are able to see, look at this. When I go to the setup now, you can find it all these properties. Sahil, are you able to observe? Ranjit, can you see the screen? While you're defining this, okay, fine. Yes, Sahil Gupta, okay, fine. What about Santosh?
Hello. Yes, sir.
Yes, Santosh, what you understood?
We created, sir, we created that pipe cross section using plane, 2D plane, right?
Yes.
And we meshed that, and we put the denser mesh around the edges so that we can, visualize clear flow and everything. And then we imported that file again, mesh file in Fluent, and we added boundary condition, inlet, outlet, all those things, right? But sir, in that I don't understand why we done scaling and everything, but overall procedure I understood.
Okay, scaling, I have not done any sort of scaling. See, suppose.
In mesh we used to scale and all those things, right?
Yes, because I'll tell you the reason. Now the reason is there is option of scaling option. What is the use of this? Suppose you create your geometry in inches in SolidWorks. You created that part in inches. Now
Yeah,
you
yeah.
imported that file into Fluent. That you want to see the
And
results in terms of meters.
okay, yeah.
See
I
now.
hope we learning everything in detail. So
Yes, yes,
I
yes.
was thinking like you are giving overview like from start and end how the
Yes,
things
yes.
work.
How, no, the basic idea I'm just putting in your
Yeah,
mind, how it is
yeah,
going to work and what important in parameters are required to do a fluid problem.
yes,
So
yes.
that I made you
And
to understand.
yeah, yeah. Everything those parameters we are learning in deep in further
Yes, yes,
classes, I guess.
yes.
And one more thing, sir, why you used the two schematic in schematic two systems? Why we added in only one system
See,
we can work?
actually, what happened here is sometimes what happened, this area it is mesh got failed because when I
Yeah.
try to update it has got failed because of complexity of mesh, it has got failed. So that's the
Yeah.
reason I've said that mesh well separately. Then I import
Okay.
it again.
And
Sometimes
is
it is
there?
not in, no, it is not mandatory every time you have to save the mesh file because in my application it is every time it is showing the error because sometimes this file will be saved in my Outlook drive, it is going to save, so it is taking a lot of time, so it is got crashed. So what I did is again I took there one more file, then imported, I imported the mesh file again. It is not that it is not in all the softwares, I mean it is not in all the versions, only in the 16 version it was showing this.
Okay. Okay. So we have to import a mesh file again.
Yes,
in
that's the reason I
CATIA.
imported again. Instead of drawing again, I have been imported that file.
Okay, okay. And is there any criteria like for quality of elements and
Yes,
everything?
yes, yes. As we have in hypermesh, right? Aspect ratio, Jacobian ratio,
Yeah,
skewness, that all you should be aware. Because in this, I'm fluent, we are not going to discuss that. If you want, in the Ansys workbench and hypermesh, we are going to teach you that. I think the people who knows hypermesh, they should be aware of this. Aspect ratio, minimum size, maximum size, warp page, that all should be aware. Then only you can understand.
yes, yes, yes. Okay, sir. Yeah, thank you.
Okay then. So I'll stop the session from tomorrow by sharp
Okay.
2 o'clock. I'll be starting the session. Okay. So please be present. Tomorrow we'll start one problem and we'll discuss how the output results we will be seeing.
Okay, sir. Thank you.
Okay then. Thank you. Thank you all.